Hey, it's Mr. Stellatano, and this video is going to be explaining scientific notation. So firstly, scientific notation, what is it? Well, it's a shorter way to write numbers. So we use scientific notation as a shorter way to write numbers. Now sometimes we have a really huge number, like the number we're looking at here. Right? So this is an enormous number. Imagine having to try to write all those zeros over and over again. It'd take a very long time, right? And sometimes we also have a really tiny number like this one. Again, writing all those zeros over and over again would take quite a bit of time, more time than you'd want to spend on this. So firstly, we need to know what the standard form is. So the standard form is just what is called the form that you're used to. So this very, very small number and this very large number are both from the standard form. The scientific notation form looks a lot neater to write down. It's a lot easier. It looks like this. So this actually represents the number on the left in scientific notation, and this is the number on the left beneath it in scientific notation. Okay. So a couple other terms that we need to know. One is the coefficient and the other is the exponent. So the number in the beginning is the coefficient, and the number, the power of 10, is always the exponent. That's what we refer to it as in scientific notation. So one thing you need to know is that if the exponent is negative, then our number starts with a 0. So this particular exponent is negative for this number. And so because of that, our number actually is a very, very small number. So negative exponent just means that your number is very tiny. It doesn't mean the number itself is negative. If the exponent is positive, then the number is going to be greater than 1. So for example, this number over here is going to be very huge, right? Because it's greater than 1 because it's a positive exponent. Now how do you do it? Well, the first thing you want to do is you want to find the decimal. And the decimal is going to be right at the end here. And so basically, you just move it across. And don't forget that some numbers have the same decimal assumed at the end. Just move it across. And then as you move it across, you count the number of steps. So you count the number of steps essentially that it traveled in order to make your number go between 1 and 9 to the left of the decimal. So we actually moved it 3 times because we want our number to be between 1 and 9. And our number is between 1 and 9 because it's right after the 5. So how many steps did we go? Well, we went 3 steps, right? And so because of that, our number becomes 5 times 10 to the third, and that's what we get for that. Now notice our original number is greater than 1, and so our exponent was positive, so you always want to make sure you check that in the end. So you want to convert this number to scientific notation. So basically what we have to do is, again, we count the number of steps in order to make the number between 1 and 9. So in order to make this number between 1 and 9, to make it the number 4, we had to travel 5 steps. And so how many steps did we go? We went 5, and so our number becomes 4 times 10 to the 5th. So remember, the exponent of 10 is how many steps you traveled, essentially. Now, did our original number start with 0? Yes. So what does that mean about our exponent? It means our exponent is negative. So that's really important. If you have a very small number, the exponent is going to be negative. Okay, and that does it for our lesson. Thank you for watching.